So welcome everyone again. The NFEL Armenia initiative is happy to have you during our discussion. And today we can already start because it's already 6-7. So today we are hosting Javier Cervera Alonso from Spain. Javier is Vice President of Spanish Association of Energy Engineers, and he is in general, he is telecommunication engineer. He is the head of energy transition at the shipping company BALEÀRIA, and also he is a member of the committee of experts of the Spanish hydrogen industry, and also co-founder of energy communities Sapiens Energy. And today Javier will present the renewable energy production and storage technologies from Spain, and some case studies, and how we can use this experience in Armenia. We will have first of all the presentation of Javier, and then we'll have a discussion. So feel free to write your questions in the chat, or at the end of the presentation, we can also give you the mic, so you will ask your questions, or I can ask to Javier. So Javier, thank you very much for accepting the invitation. And yeah, and welcome, and I guess we can start.
Thank you, Hasmik, and thank you, the NFEL organization, for this invitation. I'm very happy to be here and to share the next 60-70 minutes, first part for the presentation and the rest of the time for this chat and this dialogue that I hope it will be interesting. I'm sharing my screen, and I start because you have presented me correctly. So I switch off the video and share my screen. It's okay?
Yes, we see your screen.
Okay. Okay. First of all, if we want to talk about the renewable energy in my country, in Spain, we have to know how we use the electricity. And we are focused today on the electricity. Other day we can talk about other renewable energy related, for example, with gas, with hydrogen, with biomethane or biogas. But today we are focused in electricity. How is the Spanish electricity system? Our demand is 250 terawatts of energy. Okay, here we have 250 terawatts of energy in all Spain region, and the 45.5% it's renewable energy currently in this past year. Really, the closed data that we have is 2020, and we are near half part of the demand with renewable energy, the production. We have installed 110,000 megawatts of power, and 54% is renewable energy facilities. We can see how the demand has been moving from the past 10 years, according to the crisis coming from 2010, reducing the consumption and recovering from the crisis, using more electricity, and reducing a bit in 2019, and obviously for the coronavirus reason, we reduce a lot the demand in 2020. You can see how it's related the gross domestic product, how we improve the economy and we increase the energy consumption. And obviously the terrible COVID starting year 2020 that we reduce both the economy and the electricity demand. Here on the left, we have the power capacity. The most important technologies in our country are hydro energy, wind. We have a lot of energy turbines, park installations, solar photovoltaic. We have a nuclear, and very important, the natural gas combined cycle power stations. Here is the power installed, and on the right we have the energy balance of each technology. we can see as the hydro is producing 12%, wind is producing just exactly as the nuclear in Spain. You know that nuclear is running 24 hours a day, but wind is running when we have the resource. That means 3,500 hours in a year. Okay, but due to the installation in power, 27,000 megawatts in wind, we can produce as much as the nuclear in our country. And we depend still quite a lot from natural gas power stations. But you can see how with wind turbines, solar, 6% and increasing rapidly, and the hydro, we are already producing a lot with renewable. Here you can see the increased power in our country in the past 10 years, quite a similar quantity, but in the last 2-3 years, we are increasing wind and solar facilities. Here you can see how has been the difference between the renewable production and the non-renewable production. Last year, with complete data, 45.5. Here on the left, we have the electricity demand in the regions in Spain. You don't know the regions in Spain, obviously. And on the right, we have how the electricity generation ratio is in every region. I think that is better, this picture. If you see my country, you can see that we generate a lot of energy in the northwest of the region of the country, in Galicia, or we have 3 nuclear plants here in Catalonia, but we don't produce as much in the capital, in Madrid. But we consume the maximum in Madrid and in the Catalonia region because it's really important industrial region in our country. Okay, we have big power plant productions or plants around the country, and we have very different areas about the consumption, and we have to move with high voltage lines the electricity from the generation or production to the consumption. This is the typical consume line that we have in our country, something like 35,000 megawatts of power. During the night, obviously, we reduce, and starting the day, we increase. We go home for the lunch, and we go or finish your job on the offices, and coming back home is like the maximum demand in the country before we are going to sleep. Okay, this is very similar during the winter, a bit different during the summer, and it depends obviously of the temperature. If we have a cold week, obviously, we will use something like 2,000-3,000 megawatts more than this data that you have seen in this graph. This is a typical day. You can see here the solar production, this 6% annually. You can see obviously in the solar hours. And you can see that the wind, the green one, is similar production to the natural gas, for example, or to the nuclear. Nuclear is always running 7,000 megawatts of power, 8 nuclear plants that we have in the country running 24 hours. The wind obviously is changing according the hour or the day that we move. This is a normal day, and this is the day 3 months ago that we had the maximum wind production in Spain. You can see that near 50% of the production is wind. And obviously we reduce a lot in that moment the natural gas production. Here we have the solar in that day. What about the prices with this generation and demand that we have in Spain? Usually we have prices like 50-60 euros megawatt in electricity normally, but as you know, in the international prices and Europe prices, we are suffering terrible prices, electricity crisis in all the region, in all Europe, because we are very demanding. We don't have much production of natural gas or other fossil fuels like petrol. We have to buy everything from outside. So we have increased our electricity prices a lot. In that moment, for example, today, 8 p.m. will be the maximum electricity price in the history, 410 euros megawatt for the electricity. This is the graph for the natural gas that is really related with the high electricity prices that we have nowadays. Today, in January, arrived 185, and today, just now in the moment, today is increasing 12%, and it's arriving near the same price. So you can see with the evolution of the natural gas that is completely related with the electricity cost. So if we demand energy from outside and we don't have enough renewable production or not renewable with fossil fuels, we suffer the electricity prices in the international markets. This is the price today. This is the maximum tonight. If you add to the 410 euros megawatt means 41 cents of euro. If you add the cost for the grid, tonight we have 60 cents of euro per kilowatt. Just 1 year before we had this price, 15. I compare here the line, it's just behind these numbers. I mean, it's like 4 or 5 times more. It's crazy for the customers and the residential customers who are suffering a lot, but suffering a lot industries too. And this is the price in Europe. You can see in UK it's still bigger, higher, but in all Europe we are quite connected, and mostly hours during the day we have the similar or exactly the same price. Okay, so you have seen that we produce 45% of the electricity with renewable, but we want to increase. We have a plan, integrated national energy and climate plan for the next 8 years from that moment. Okay, we want to reduce the greenhouse emissions. This plan is from 1.5 years ago. Now with the Green Deal, European Green Deal, this has to increase to 55%. That is crazily, but we are working to obtain that. In total energy, not only electricity, we want to have 42% in 2030. And about electricity, 74. If we compare to the 45 that we have in 2020, we have still a long way to arrive in 8 years to 74% of renewable. You know that renewable energy, it's like not firm energy, not consolidated. You can have 50% of wind production in one moment, and 1 hour later can reduce half part of that. So to obtain 74% of renewable just in a moment on the system, you need like backup, a lot of natural gas plants, for example, or nuclears, to be ready for this moment that the sun can go with clouds or the wind stops suddenly in some minutes. Okay, this is the evolution that we expect. We have currently 60,000 megawatts of renewable facilities in Spain, and in the next 10 years we have to arrive this volume. You can see that the increasing is in wind and solar, basically. So this is the power in 2020, the 110,000, 111,000 megawatts of power, and we want to increase 160,000. Which technologies? From 28,000 megawatts of wind turbines, near double the quantity, 50,000. And we want to increase a lot in solar, from 9,000 to near 40,000 megawatts of solar. And you can imagine that in 8 years, in 2030, we will consume similar electricity quantity as we are doing nowadays, except that we'll have more electric cars that can increase 5–6% of the demand in the country. So if you have seen that our demand is maximum 38,000 megawatt, if we have one day that is sunny and some part of the wind, we have a lot of more production with only two technologies, renewable technologies, that we are demanding. So if we don't storage this energy, or we don't use to produce, for example, hydrogen, we will lose this energy. But we are in the way to construct these facilities in Spain. This is the picture that demonstrates that we are on the way. Just in the end of the January, the electricity national company said that already we have 42 gigawatts of power plants, renewable, in photovoltaic and wind and solar. And there are 144 new projects with access permissions. That means the promoters, for sure, at least will install 90% of this capacity. I mean, it's like crazy. It's a lot more than the objective that we have to increase from 2020 to 2030. Okay, and some that still are asking for the permission, and other projects that the national electricity company said your project is not okay and not possible to connect to the grid. Okay, so we are in a good way because we have a lot of projects to arrive to the objective that we have in 8 years. We are installing this kind of plants in Spain. This is the biggest in Spain and the biggest in Europe in that moment, 500 megawatts in a region in Extremadura. The owner is Iberdrola, the biggest electricity company here in Spain, and near 1.5 million solar panels. The second biggest is this one in the same region, 300 megawatts. Every 3–4 weeks, a new plant similar size of these ones are connecting to the grid nowadays in Spain. These are good news, but we have these problems now in Spain, that is the social rejection. People on the towns, basically on the towns, because these big plants are near to the small towns, they are rejecting the renewables because they don't want to see this view on the fields. Okay, it's something, in my opinion, that obviously I don't understand. Okay, I suppose that later you will tell me, but I suppose in Armenia you don't have this problem. During the COP in Glasgow, I was talking to the energy minister of Chile, that they are growing a lot, and he told me, still we don't have this problem, but we are listening that in Spain you have this problem. A lot of people has the power to stop some projects. So for us to arrive to the objective is not so clear if we continue using these big pieces of land to install big projects. Okay, so we have solution for the social rejection. That means to install and to integrate the renewable in other ways that you don't use the big lands near the towns or big lands that currently they are using for agriculture, etc. Today I presented 3 options: using agro-photovoltaic, that means mixing the panels with agriculture; using energy communities, that means using the roof of the houses, the facilities on the towns, big factories, etc., to install the panels and sharing the electricity. And the other is using the water that you have with floating photovoltaic. Starting with the floating photovoltaic, I will show you here a project that is 10 kilometers far from my home. I visited with professionals this photovoltaic, and it's in a dam for piping water for the irrigation fields near to this area. 850 kilowatts of solar panel, you use a free space, because if not, you have only the water. Non-impact and less water evaporation. You lose less water because you have the cover of the panels over the water. So it's an integrated solution. In Spain, we have a lot of these water deposits or pumps ready for irrigate with electric pumps the fields. So this electricity is directly used on the pumps to move the water to the fields. It's not connected to the grid. But we are starting to install other projects. For example, in this big lake, it's 7 kilometers long, and we are installing this kind of floating panels too in that project. You can see it's in this small corner, and you can see big projects near the water here, like 50 megawatts plants. We have a lot in Spain, but nowadays we are starting to use these places that doesn't impact with the territory and the field. This is the facility finished. And here the promoter has installed different solutions to test. Here panels with double phase photovoltaic and white carpet behind to reflect the maximum power of sun. Here, like in a disposition, the panels, here another, and here another. They have put different to test the production in every situation, the panels. This is 1.2 megawatts of solar power. You use free space, non-impact, and in this case is grid connection. I showed you a video about this project, how has been installed. Okay, you can see here already. This is a big lake that is in the center of the country, and you can see different inclinations for the panels, different structures, because it's a demonstrator to test the technology. And after testing during 1 year the production, they will increase the number of panels using the best distribution that produce a lot more electricity, and the maintenance of the panels are lower. You can see here the installation with inverters, the workers. You respect the environment because you are using the panels over the water. So this is a beautiful facility. Okay, we continue. Other solution is the energy communities. This is a specific solution here in Spain. Why? Because we have a new law from 2020. We have a new law from 2020 that allow to install centralized solar panels, centralized small wind turbine, electricity renewable production, and you can share between the neighbors in the neighborhood in an area of 500 meters. Okay, so you can install 100 kilowatt and you can share with 150 houses, and you can share 1 kilowatt, a bit less, and you don't pay for the use of the grid. You don't have to install cable from this central installation to every house. These facilities injecting the renewable production to the grid, the distributor grid, but every house share partly this facility, not paying for the use of the grid, but you can do only in a reduced area, 500 meters, but allow to share 100 kilowatts with 100 to 200 houses. It's quite nice new business model to use a lot the roof, installing a lot cheaper facility if you install 100 kilowatt and you can share with 100 houses, a lot cheaper than if you have to install 100 small facilities, everyone in every roof. So you install the roof and using the grid, you share with the people. It's like the production, the solar production that you have in these panels is not to cover the demand of the building. You can share with the building too, but the objective is to share with the houses. And partly of this solar power is going through the grid to every customer that is connected to the facility. In Sapiens, that I'm a co-founder of this cooperative on energy communities. From this year, 2020, we have done already 20 energy communities in 20 different towns in my region, more than 1,800 kilowatts of photovoltaic power. We have added already 4 facilities with storage about 100 kilowatt hour. Already more than 500 residential users are enjoying self-consumption very cheap, 15 small business, and we share sometimes with the public building who give us the roof to install the panels. So this is the second model to increase the renewable energy, non-impacting the fields with big photovoltaic facilities in the country. The third one is the agrivoltaics. It's installing the panels just together with the agriculture. We have this project sharing Sapiens with another promoter. It's 1.5 megawatt of power plant will be installed in 2030. We have already the resources to do, but this is very curious project because you test the different panels distribution. You can see here, like together, here behind is this picture, and you plant the different agriculture in the bottom part. We are doing two products. This is the avocado, and this is the fruit of the dragon. So in 2 areas, we are growing during 1 year the different fruits with different size of panels on the top here, and after 1 year we check the productivity of the agriculture and the productivity of the panels, and we'll decide for the rest of the project which is the solution to install, like the panel distribution and which agriculture, which fruit is the best to plant and obtain better economy feedback. Okay. So we have seen 3 solutions to install renewable, but we have said before that in 2030 in Spain, we have this problem. A lot of renewable, a lot more than the demand that we have just in a moment. So we need to store. If not, we will lose a lot of renewable electricity and the projects will not refund back the money as soon as it's planning the business case. So which is for me the best solution, added obviously to install lithium batteries in the buildings, in residential houses. I have one in my home, for example, for my house and my electric car. But if we want to keep an storage during the production to use some hours later, all this excess of renewable that we'll have in 8 years, we need big projects. I show you here a project that is installed from 4 or 5 years ago in an island in the Canary Islands in Spain. This is the island of El Hierro. Only 10,000 people living there, and this is the electric load that they have. And the demand in power is no more than 4 megawatt of power in the maximum moment of the day, okay? So this is the solution that has been installed to try to do this island completely free of emissions. I mean, completely using 100% of renewable energy. How? Installing these wind turbines, 11.6 megawatt of power, but obviously when the wind is not running and the inhabitants need electricity, you will need another production to complete the electricity. So they have installed this storage, a dump or deposit here on the bottom part, and 700 deposit higher here on the top. So this is the lower reservoir for the water, the pumping station when there is more electricity than is needed for the island or the customers. The rest of the electricity is pumping with some of these motors, engines, pumping electricity to the top. All right, to the top is full of water, and when it's running less than the demand, with the hydraulic station is producing the electricity that is needed to complete the just electricity production that we have in that moment with the wind turbines. With this project, with this storage, they have adapted the production of the wind turbine facility to the demand of the customers and small business that exist in this small island. We have bigger projects. This is the small project, but really important because it's in a small island and it's covering the 100% of the demand with the renewable production in the same place in the island. We have this other, it's the biggest in Spain, and for sure one of the biggest in Europe. This is near to my home in Valencia region, 40 kilometers far. We have a dump here. We have a hydraulic station from 70 years ago, and 5 years ago was installed this dump on the top. So when the electricity is available or is exceed on the system, use electricity to pump water to the top, and when it's needed to complete the renewable on the demand, you turbine the water coming back to the original dump, okay? The power is 900 megawatts, and you can keep or produce electricity during more than 12 hours continuously with this power. So this is real important system. Just here on the right, we have a nuclear plant, 1,100 megawatts of power running 24 hours. But you can play with these systems with the difference of price that we have during the day. In Spain, we have, in a day, we have 24 different prices according the hour, okay? During the night, like we use less, usually it's cheaper, but can happen that in the time that you arrive home can be really expensive. This is a day in October. Today, it's twice this price, for example. So during this time, it's cheap electricity. You can buy the electricity and pumping to the top. You keep water and you turbine in that moment, and the promoter has these incomes for the electricity in that moment. So it's promoting that you use the free or cheap for electricity. Free will be in the future when exceed too much renewable energy. Instead of losing the electricity for free, will be used to pump, okay, and to storage. But you can play at the moment, storing or pumping a bit in the cheap hours and using the hydro power plant to produce electricity in the expensive hours in the day. So if you compare, for example, both solutions, storage and integration, in your lake, in Sevan, for example, you have here on the left a gas power plant, a big one, and I have seen in the Google that you have a high voltage power line crossing here. And if you check just here in this short space, you have 700 meters of difference. So this is a good place, for example, to install a dump. You have the high voltage line to connect the production, for example, floating here with near 200 hectares of water that is represented in this square, just in this square, a small one for the size of Sevan Lake, obviously, it's like a point here. You can produce 70 megawatt. When you have the sun, you can keep this electricity just pumping to the dump, and when the sun is going and you need power, if you have to run, for example, with natural gas, even you have cheaper natural gas that we have in Europe, someday can be more expensive, and you can keep quite cheap solar electricity in a dump with this facility here and use during the moment in the night or before the night when you need a bit more electricity and the options to complete electricity are more expensive. Okay, so this is the presentation that I have for today. For the discussion, I have showed you how we have the renewables in Spain. We have installed this renewable during many years, but now that we have to continue our objective growing a bit more, we are starting with the social rejection problem, and we have to invent other solutions to try to continue installing a lot of renewable energy.
Thank you very much, Javier. It is, of course, very much interesting, especially the solution for storage technology. So, dear participants, if you have questions, we have still time, 15 minutes, so you can ask your questions. Either you can write in the chat, or you can raise your hand, or just like that, you can ask. And yeah, we have the first question from Carlos. Yes, Carlos.
Yeah, thank you very much for the great presentation, Javier. And I apologize that it's a bit noisy here. I'm at university. But I wanted to ask you perhaps slightly, it's a big dilemma, the topic of nuclear energy. And I wanted to ask you about how reliable and safe, and especially how feasible it is, to shall go forward with nuclear energy to meet the lack of supply that we have from renewables in the future. How do you feel about nuclear energy, at least in the context of Spain? Oh, sorry, you're muted.
Okay, Carlos, thank you for the question. Carlos is asking about the nuclear in Spain situation. We have 8 nuclear plants, and from 20 years ago, we can't install more. The politicians decide that we don't increase nuclear in Spain because, like you have seen, we are increasing quite a lot in renewable, and apparently, if we storage the renewable, we have enough power for the demand that we have. I have been showing you the electricity demand that we have currently, but as I told you, we will increase a bit in electric cars, but it's short 5–10%, but to produce a hydrogen that we can dedicate another day for that, we are going to use a lot. So nuclear, it's an electricity that if you install and you have an investment for a long time, obviously, 40 years, for example, can give you a quite cheap price and fix to produce hydrogen in a good way. If not, you install electrolyzers that are quite expensive. And if you want to use cheap electricity, you have only cheap electricity if you install solar panels next to the electrolyzers, directly connected, for example, and not using the grid for transmitting the electricity. So nuclear can be an option to decarbonize natural gas sector, changing that for hydrogen. In Spain, with all the renewable electricity, I think that we have enough for substitute the fossil fuel electricity production, natural gas basically on some cogeneration, and substituting the nuclear that are closing or stopping in 10 years. But I think that nuclear can be an option, but France, for example, now is installing new plants and the cost is so expensive, and they are finishing one with a lot of problems that I'm not completely sure. If you want to plan a nuclear plant now, it will be constructed in 8 years, for example, or something like that, with the rules of regulation in Spain or Europe. From the moment that you design the project until you install the nuclear, you need 8 years. So for the moment and to run for the next 8 years, we have to install renewable, and nuclear can be discussed for a long time thinking in hydrogen. But first we have to test that hydrogen is okay. And we are doing now in the next 2 or 3 years with a lot of subsidies in Europe, we are testing the business of hydrogen.
Carlos is asking if we have time for another question. Let's see if there are other people who have questions to give the mic to everyone, or yeah, and if there are questions.
Several years ago, Armenia also had such idea construct hydro-accumulation station in Sevan Razdan Cascade, but not solar energy storage. This is night and daytime energy demands regarding. Maybe in future we also will come such idea construct hydro-accumulation station. If we will be construct 1,000 megawatt solar energy station.
Yes, so if I understood your question, when I was searching about your country, I've been visiting your country 7 years ago, nice and beautiful country. My couple is from Armenia. And I saw this kind of project that you have. This is the Sevan Razdan Cascade, and you have the water here, and you have hydro energy to produce electricity, but you don't have pumping. This is a nice place to adapt, to pump water. The problem is that you don't have a dam here to keep the water, but with not so high investment, perhaps you can move this production to be an storage, for example, in this area, in this plant in your country.
Thank you.
Thanks for your question.
Thank you, Javier. Thank you, Aram.
Hasmik.
Yes.
Hi. Hi, everybody. I have one question about the same topic. If we decide to build hydro accumulation plant, that means that we need some lands to for that station. But in this case, we may face with the dilemma: use this land for agricultural purposes or for the hydro accumulation station. And as a continuation for the question, during the last days, I have heard that European Union talk about some how to say casualties of big water reservoirs. That they say that in big water reservoirs during the time can be accumulated some quantities of methane, and these also can bring to the contribution in greenhouse gases. So if we decide to build big dams where we need to collect the water, and can this problem be solved in any way, or no? The last part of the question is due to the news during the last days, because there are some how to say talks about Sayanashushan hydropower plant, and European Union have some concerns about this. So that's why I ask if we try to build new dams to collect more water in that territories. Can we have such issues?
Okay, thank you very much for the two questions. About the first question, it's the problem that I have showed you that we have here in Spain now, the social projection, like we use this land for the agriculture or we use the land for energy. We have, in my region, we have a lot of land with the wine production. okay, if we continue increasing the temperature that we are doing in 15 years, they will not grow for more. So it's like in Spain, to produce all the electricity renewable with solar, we can use only the 0.4% of the land of the country. I mean, we are a big country. We have to search the places to put these big solar plants. Obviously not in the best agriculture areas, obviously. But if we finally can contribute 10-20% of the necessity of the objective with agrivoltaic, with energy communities, using all the roofs, using the water irrigation deposits, etc., you help to not use or not have this friction with the residential people that is near to the land that you are promoting for the project. So, but we are in a climate emergency. I mean, I understand this discussion 20 years ago. We had time to discuss about that, but now we are in an emergency. If we don't solve that, we'll not grow more wine in 20 years in Spain. So, I mean, we have to discuss, obviously, we have a lot of land, but we have to advance in the facilities. About the first question, about Armenia, I know some areas, but I've been 2 weeks there. I don't know exactly which are I suppose that you have some areas. I know where the project of 50 megawatt power is in the west-east of the country, in the corner of Lake of Sevan. You have a promotion there from a Spanish company, I think. I saw in Google, and apparently it's not agriculture areas there in that project, but it's only 50 megawatts. You need a lot more to improve, like we are doing in Spain. Second question. The projects in Spain are in two ways. Using currently dams that we had from 70, 80 years ago and constructing only one on the top, okay? Or we are promoting projects getting the water from the sea in the level C, in the sea level area, okay? Getting this water and constructing only one dam too. There are projects with an impact in the environment, obviously, because you are using space, etc. But when you put a new highway and crossing 3 towns, people doesn't say anything. I mean, and it's so important, the new highway, that it's so important, the renewable electricity, to avoid the natural gas and the coal plants in our country. So I think that there are solutions to install perfectly the dam or the pumping solutions. I haven't read about the news that you have telling me. I will search to read about this news. But I think we have many projects already running in Spain, and we are promoting a lot with this kind of storage. And it's really nice storage because you have the water on the top, and when you need the power, you put the power on 100, 200 megawatts, and it's running the time that you need. It's not like the wind or the sun that they move on the production. So I think that is the big storage production that we need. We can install the small one. I have 10 kilowatts here in my home, but it's to manage my home only. We have factory, we have business, etc., etc. So I think that is an important to obtain a self-renewable consumption near 80% in Spain in the next years. I mean, with a lot of electricity that we are installing, renewable, that you have seen the numbers. And with storage, I think that we can produce more than 80% in only 8 years, but we need to keep with this kind of storage.
One more question. What solutions are for example, wind power plants after their working time, because we need to utilize those, and how you see the solutions for this issue?
Sorry, I didn't understand. For the wind turbines after the, sorry, can you repeat?
You mean recycling? Recycling?
Yes.
Okay. Yes, we have many projects about how to do about these materials. You have two ways. You can recover. It's a bit quite expensive still, the technology, but it's just starting to recover the components. Another is to try to adapt for furniture on the public spaces. We are doing a lot now in Spain. We are using rejected plastics, etc. And we are doing seats for the people on the street, doing the box for the plant. I don't know in English, the place for the plant at home, furniture at home, etc., etc. Now in Spain, we are using a lot of rejected plastic. And for a special furniture or big places on the public space, we have already two experience in Spain, the wind turbines material that when they finish after 25 years, basically. It's important, and the lithium too. We have to recover the lithium after 20 years. Or the car, for example, in my business in the BALEÀRIA, we have a new terminal, and I'm installing 100 kilowatt hour of second use of electric batteries for the use in the terminal, because it's like not so requirement as an electric car that you need the maximum power from the battery to the electric engine. You can use after 15 years this kind of batteries for a storage in a building that doesn't have so power requirements. So second life batteries, we are doing some projects too now in the country.
Thank you, Javier. We have another question from Jeremia. So the question is, how much does 100 megawatt of power cost with the 10 gigawatt hour reservoir? Or how much does 1 unit power with 100 unit reservoir?
For storage, if you add the photovoltaic facility to the dump, the approximately price for the dump, it's about 2,000 euros per kilowatt. That means 2 million per megawatt. With this price, you can install the dumping system, the pumping, and do the project on the mountain. Okay, with this approximately, this is the cost of the projects that we are running here in Spain. Projects from 100 megawatts to the maximum that you have seen, 900 megawatts. This is approximately the cost of the storage when you do the dump. I mean, to do a bit bigger and to keep more hours is not so expensive. You have done already the pipes, you have used already the machines to construct the dump. I mean, to increase storage with a bigger volume is not so expensive. The basic is usually basic is for 10-12 hours of capacity, but if you want the project for 24 hours, I mean, it's not double. But really it's because like we have this kind of prices in Spain, and apparently we have sun during the day or wind. You keep energy that you will use at the end of the day. I mean, the probability to need to keep electricity in a dump for the next 7 days is not so necessary. We don't have 1 week completely cloudy in our country. So the design is to keep 10-12 hours. That means when you start to use the power with this water, you use 3 hours, you reduce the power, and with this 12 complete hours storage, you can run 24 hours, for example, adapting to the electricity demand that you need to complete from the other production that you have in that moment, and you add on this storage. So this is the approximately cost, okay? Approximately, but it depends a lot from exactly the size, the place where is the dump, etc., etc.
Okay, thank you, Javier. And we have one question from Tigran Karapetyan. So yeah, you can unmute yourself.
The micro is off, micro.
Thank you very much for your interesting presentation. Yeah, it was very interesting to know energy sector of Spain. And I have one question regarding to the hydro accumulation, the efficiency of the electricity in Spain experience, with the operating, how much is it in percent, like 1 kilowatt hour you storaging it and final for uses percent.
It depends the technology, the pumping, but between 65 and 75, 80% of the efficiency, approximately in this range. So if the electricity is cheap, that means when you have exceedance, you can't storage in other technologies. If the electricity is cheap, you can lose 30% of the electricity in the efficiency of the system. Approximately.
Okay. Thank you.
The good thing is you install and you spend this money, 2 million per megawatt approximately, but you install because you are going to have a lot of cheap or free exceeded electricity. So the maintenance or the operational cost, that is the electricity for the 20 or 30 years that the project will be running, is very cheap. So losing this efficiency is not really important.
Thank you.
Thanks to you for the question.
Thank you for the question and for the answer. It's already 7:03. Are there other questions? I guess we can have one more question, and well, if there are not any other questions, I will ask the last question maybe. Actually, I'm wondering how you deal with evaporation when you have when you construct the dam. How you deal with evaporation if it's
Yes, you have another land of water and that can be evaporated, obviously. But this quantity, obviously, you do this kind of project if you are using a water river with a dam, existing dam. You have the evaporation in this dam, and you are adding another dam that can evaporate the volume of water that you have in that river. The evaporation, I don't remember the numbers, it's short, but obviously you have this evaporation. You have to install this kind of projects in places and big rivers when you consider that in the next 20 or 30 years, you are not affecting to the quantity of water that the river needs for the agriculture or the human consume going down on the river. If you use a dam with water river, if you use the ones that you are catching the water from the sea, it's not the problem, obviously. But yes, you have to consider that you install this kind of projects in a place that you study for the future, that you will have enough water. You lose a bit, but you are giving or catching something better, that is storage, renewable energy storage.
Thank you, Javier. So if we don't have any other questions, or do we? Tigran, you want to ask?
Regarding to the floating solar plants, I want to share with you some information. In Armenia, we are going to install 150 kilowatt pilot projects with the French company and with the FASEP program. And already the plant is in design phase. So I hope in summer we already in Armenia have first floating solar plant. My question is regarding the floating solar plants. Can you share with me the price for kilowatt unit for the floating one?
Yes, for example, in the energy communities in Sapiens, we have promoted a project in a small town in the Pyrenees in Spain, between Spain and France. There we have installed 3 different energy generation with biogas, with 40 cows, with this manure. We are producing 100 kilowatts of electricity. 3 solar panel facilities, 2 storage, and 7 electric recharger points. One of the 3 solar facilities is floating. It's a small one, 40 kilowatts, and the cost that we have asked, and we have 3 offers, it's 1,300 euros per kilowatt instead of 800 euros per kilowatt if you install panels on a roof. Okay, this is the difference here in Spain for the cost of installing a small. It's a small. If you do a bigger, the difference is lower. Okay, but it's quite good price because we are using a small deposit that we have, and we don't affect other roof or other space. It's in a place that the roof and the houses are really old and difficult to install the panels. So we decide to do in the deposit the 40 kilowatt. This is the real price different nowadays here in Spain.
Okay, thank you very much.
Thanks to you.
Thank you very much, Javier, for being our host, being our guest speaker. This is, of course, an honor for us and a pleasure. And thank you to all participants for active discussion and for your interest. And after this, we will